Section 14.1b, we're going to work on different orders of integration with our iterated integrals, and sometimes one order of integration may yield a simpler problem. So first I want us to sketch the region whose area is represented by this iterated integral. So the integral from 1 to 2, the integral from 2 to 4 of dx dy. How you start this off is basically pay attention to what our inequality is. So looking on the inside integral, it's with respect to x, so I know that x must be bounded between 2 and 4. Looking at the outside integral, notice it's with respect to y. That tells me y is bounded between 2 and 1. Now let's see how that translates onto our graph. Y values are between 1 and 2 horizontally. X values are between 2 and 4 vertically. So we're talking about this rectangular region. Because this is written dx dy, we're going to be summing up the rectangles in the y direction. They're going to be stacked up like this from y equals 1 to 2. This would be horizontally simple. So let's take a look and see what this integral would look like with the order of integration reversed if I had a dy dx instead. Now because this is a very simple region, all I'm going to do is switch it so that my 1 to 2 is on the inside integral and the 2 to 4 is on the outside integral. Let's take a look at another one, but this time it's not going to be a rectangular region. I'm going to have a function in here as my lower limit of my inside integral. So pay attention right now, this is dx dy. First thing I want you to do is sketch the area that is represented by this. So in order to do that, I would suggest that you write out the inequalities. So the x's are bounded between y squared and 4. And then on the outside, we have y bounded between 2 and 0. So now sketching this, we have x is less than or equal to 4. So that means we have a vertical line. X equals to y squared. That's going to be a parabola that opens to the right. And then we've got the y values bounded between 0 and 2. Again, these are horizontally simple sections, so they're going like this. Again, bounded on the left by the parabola, bounded on the right by the line, all the way from 0 to 2. So now let's see what this looks like with the order of integration reversed. So let's reverse the order of integration. This is going to be dy dx. So what is on top of our rectangle is the parabola, but we're going to want to write it instead as y equals to the square root of x. So positive square root of x goes on top, and what is on the bottom of each of these rectangles, it's 0. Now where are we going to be summing up these rectangles? They're going to go from left to right. So the smallest rectangle is going to be at 0, and the largest rectangle is going to be at 4. Now I'm going to have us integrate one of these. Now do you think the first one would be easier to integrate, or the second one would be easier to integrate? Let's go ahead and just do the first one. And the integral of a dx is an x from y squared to 4. So we'll plug it in, 4 minus y squared dy. And then we have 4y minus 1/3 y cubed from 0 to 2. 8 minus 8/3 is 16/3. Let's do the other one just to compare. So the integral of a dy is a y from 0 to radical x. And when we plug that in, we just have radical x dx, x to the 3/2 times an extra 2/3 from 0 to 4. 2/3 times 8, or 16/3. Next example, let's sketch the region whose area is bounded by y equals to 4 minus x squared and y equals to 0. I want us to write the iterated integral in two ways. So let's first take a look and see what the region actually looks like. Y equals to 4 minus x squared is going to be a parabola that opens down, has a y-intercept of 4 and x-intercepts of 2 and -2. And then the other one is y equals to 0, which is the horizontal line. So we're talking about this whole region right in here. If we were to look at this as horizontally simple rectangles, then we want to consider our bounds for our integral, and that's going to be with a dx dy. These horizontal pieces are going to be summed up from 0 to 4, and then our x's, so they're bounded on the left and right by the parabola, but we need to write this equation in terms of x, so that would be x equals to the square root of 4 minus y, and x equals to negative square root of 4 minus y. One being on the left side, one being on the right hand side. So I've got positive radical 4 minus y and negative radical 4 minus y. So I'm going to write those in. I've got 0 to 4, negative radical 4 minus y, and positive radical 4 minus y. If we were to have vertically simple regions, let's take a look at what our bounds are. On the left-hand side, the x's go from negative 2 to 2, and the top and the bottom of our rectangles are 0 and 4 minus x squared, our parabola up at the top. So when writing our iterated integral out, being vertically simple, or dy dx, we've got negative 2 to 2, then 0 to 4 minus x squared. Now this one I think you can tell which one might be a little easier to integrate. If you guys want to double check, you can integrate and check to see you get 32 over 3.